Hi science students, we're going to talk about Newton's first law in this video. Now you might want to pause the video at this stage and write this definition down, and then I'll have a bit of a chat about it, so go ahead and do that. Okay, so if you've managed to write that down in your notes, then I'll talk about it now. So the first law of motion, which sometimes you'll see associated with this word, the law of inertia. And it states that a body will remain at rest or in uniform motion in a straight line unless acted upon by a force. Okay, so let me show you a bit of a demonstration of this. Okay, so we've got our robot with the box here. All right, now at the moment the box is stationary. There is a net force of 0 acting on the box. Yes, there is the force of gravity acting downwards, and there's a normal force of the floor, or this, in fact this is ice, a frictionless surface made of ice, which the box is sitting on, and that's pushing back upwards. But those forces are equal and in magnitude and opposite in direction, so they are currently balanced. So the net force acting on this object is 0. So the box is remaining stationary with a velocity of 0. Now, even though the velocity is 0, it's still what we would term a constant velocity. It's constantly 0. Now, I'm going to get the robot to push on the box. So I might just take this this way, and we can see that the box heads off with constant velocity. I'll just reset that and clear it. I'll return the object here, and I'll give us a bit more room to watch this happen. So the robot pushes the box and off it goes. I'm just going to let it go slowly this time. Now in this case the box is moving with constant velocity. Now unless another force acts on this to stop it, it will move with constant velocity. This time it's the same as before, it's just not 0 anymore. So if I push back in the other direction, it stops the box and turns it around. Okay, so Newton's law pertains to whether an object will remain stationary or remain at constant velocity. Okay, now unless you apply a force to an object, it's just going to keep on doing what it's doing, either remaining stationary or moving with constant velocity. So, some examples of Newton's first law. So I'll go over to this one now, and once again, if you want to pause the video at this stage and write these examples down, you can. I'll give you a chance to do that, then I'll explain. Okay, so we've got a couple of examples here. Once again, I've got some animations to show you to demonstrate these. So a car stops suddenly, the passengers feel that they are thrown forwards. Okay, so let's look at this picture, this animation. I'll just bring it across. Okay, and we can see here, this person is in a car and they're not wearing their seatbelt. The car crashes into a brick wall. So in terms of Newton's first law, well, the car has an external force act upon it. That is the brick wall, pushing it and stopping it. Okay, so the car changes its velocity, but the person who's sitting in the car, their velocity remains constant. They keep moving forwards with the same velocity they had while they were in the car, because no external force acts upon them. Okay, so the car has a force acting on it, but the person doesn't. Now, of course, we would be very familiar with a piece of safety equipment that would prevent this from occurring, and that, of course, is a seatbelt. And the seatbelt would provide a force, so the person would be pushed by the seatbelt and held in place, and their velocity would change and eventually become 0 like the car. The other example that's given here is a package sitting in a truck, or maybe I should say on a truck there. and is not secured, it may be left behind when the truck drives off. So something like this. So I think they actually wanted the car to come off the truck there. They're not taking very good care of the suspension and the rear bumper of this car. But anyway, this could occur if an object is not attached to a truck. So right now, at the beginning, the truck and the car have zero velocity. Now, the truck applies a force is applied via the engine to the wheels, so that changes the velocity of the truck and causes it to accelerate. So anytime velocity changes, we have acceleration or deceleration, and so the velocity of the truck changes, but there's no external force acting on the car, so it remains with a velocity of zero, horizontally at least. Yes, it accelerates downwards vertically, but we'll just keep it simple. Horizontally, the car remains with a velocity of zero and stays in the one spot pretty much. Gets dragged along a tiny bit, but pretty much he's staying in the one spot. So, sort of opposite examples of the same principle, where in this one the person has a certain velocity greater than zero and they stay at that velocity. Here, this car has a velocity of zero and it remains with a velocity of zero when the truck drives off. So, that is the basic principles of Newton's first law. Oops. So, go ahead now and... bear with me for a sec. This is the one I wanted. So, those are the basic principles of Newton's first law. So go ahead now and try some of the questions that are set and start to master this first law of motion.